Hey guys, my name is Omar Sevilla from San Diego Miramar College. I've been teaching here since 2005. At this time, we're going to talk about camshafts. But before we start inspecting the camshaft, we have to be able to identify kind of like the anatomy of the camshaft and what exactly are we looking at. The Toyota 2GR engine has 4 camshafts. It's a dual overhead cam engine with variable valve timing. So this camshaft is an exhaust camshaft for bank number 2. How I know that is I looked at the tone wheel that's on this camshaft, and this tone wheel is the component that tells the camshaft position sensor the location of this camshaft during the engine's rotation. By looking at the location of the camshaft position sensor and the location of that tone wheel, I can identify which camshaft I'm looking at. There's a couple other things on the camshaft that's unique to every camshaft, and it's called the journals. The journal is the location of the camshaft that actually rides on the camshaft bearings, either in the engine block or on the cylinder head. So this particular camshaft has 4 journals, and the journals are numbered from 1 to 4 from front to back. So the front camshaft journal is this front one here, and this journal is larger than the others, and then it has these oil control passages. This engine does have variable cam timing, so it uses oil pressure to adjust the advance or delay of this camshaft to control the amount of timing in letting the air in and out of the engine. So that's journal number 1 is unique on this engine. Journals 2, 3, and 4 are all the same size. They're just in different locations. They don't perform any special function besides stabilizing or holding the camshaft in its place. The other thing that we identify, the Toyota 2GR is a V6 engine, so we have 2 lobes per cylinder. So these 2 lobes are for cylinder 2, these exhaust lobes are for cylinder 4, and these exhaust lobes are for cylinder 6. Once we've identified which camshaft we're working on, where the front of the camshaft is, where the rear of the camshaft is, and which camshaft lobes we're looking at, we can start doing our inspection. Just like I said before, any machine surface, we want to look at the smoothness of that surface. We want to look for scratches, gouges, any rough spots. We drag our fingernail across that surface, not just on the lobes, but also on the journals. Any scratches indicate either failure or potential for premature wear. So sometimes these components get scratched while they're out and we're inspecting them. So we want to make sure we prevent any of that. The tool that this camshaft is sitting in is called a V-block. So I'm going to remove this camshaft from the V-block just to show you what it looks like. This is just a block of metal, and it just has a V cut out of it. And what this does is it gives me a location to kind of saddle that camshaft in so that I can rotate it, and it's on a fixed surface so that I can make some measurements. When I'm using the V-blocks, it's good practice to make sure you're using the proper location of the camshaft, and then I always like to put a little drop of oil on all the points of contact. This way, when I rotate my camshaft by hand, it rotates nice and smooth, and I don't have any jumpies when I'm trying to take my measurements. So the first thing we need to do before we start checking the lobes is we want to take a look at the camshaft journals. So after inspecting them for scratches and gouges, sliding your fingernails across them, we would refer to the manual, and this manual is going to tell us the specifications for the camshaft journal diameter. We would compare our measurements to this chart here. And you'll see journal 1 is different than the other journals. For journal 1, the unit of measure is over 1 inch or over 35 millimeters. So I'm going to use my 25 to 50 millimeter micrometer. If you are not familiar with using micrometers, or if you've never learned to use a micrometer before, we have a couple of training modules. One is in the Ford student training website, and the other one is in the Chrysler student training website. You can go to Precision Measuring Tools, and they're going to do a really good explanation of how to use this micrometer. And then also, of course, you can always contact me, and I'm happy to do a one-on-one lesson with a tool like this. But I'm gonna go ahead now, this one's got a digital readout. We'll go ahead and just take the measurement, compare it to our specifications. So I gotta remember when I'm using a micrometer, I'm gonna rotate it from my thimble, but I'm not gonna clamp it down from my thimble because I can stretch the frame. So I'm gonna use my ratchet, and when that starts clicking, that means we're at the proper tension for our measurement. And then I wanna make sure that this thing's nice and tight. So I'm gonna slide it around, and I wanna make sure that there is no free play on my measurement. Once I'm sure there's no free play and I got that nice and snug against my journal, I'm gonna go ahead and rotate the lock, and that's gonna lock my measurement into place. And then I can very carefully slide this off the camshaft journal. So I'm showing 35.95 millimeters. So I'm gonna take that measurement and I'm gonna compare it to my specifications in the book, and that's going to tell me if this camshaft journal is acceptable to go back into the engine for service, or if the camshaft would need to be replaced based on that. I would go ahead and continue measuring journals 2, 3, and 4 and compare it the same way. All right, so the cam lobe is the part of the camshaft that, as it rotates, pushes on the rocker arm, which pivots and pushes that valve open. And then as it ramps down, that valve closes. So that rocker arm just rides on this surface, and when this lobe comes around, it pushes that rocker down, and then the valve spring pushes it back against the cam. So what happens over time is the peaks of these lobes can wear down. Usually it's because of lack of lubrication. So the specification here for my cam lobe height is 44.26 millimeters. So I'm gonna go ahead and grab my 25 to 50 millimeter micrometer again, rotate my thimble out to over 44 millimeters, and I'm gonna do exactly the same thing as I did on the camshaft journal. So we'll go to 45 millimeters, and I'm gonna rotate that camshaft lobe. I'm gonna get this micrometer right on the peak of that lobe. I'm gonna rock that around, make sure I'm in the right spot. Still feels a little loose, so it really takes a lot of practice to get a feel for how a micrometer feels when you get the exact right measurement. I lock that down, and if you're not sure, you should be able to push the micrometer all the way through and pull it all the way through with just a little bit of friction. So here I'm showing 44.17 millimeters. So that's a little smaller than my spec. So I'm gonna take a comparison. It says the minimum cam lobe height is 44.112. I have 44.17. So we're gonna go ahead and call that good. My camshaft lobe is taller than the minimum specification. So now I would go ahead and I would measure the additional 5 lobes and compare that to the chart, and that would help me identify if this camshaft is ready for service.
This concludes our video. Thanks for watching, and please be sure to check out our social medias. Until next time.